You know, when you look up at the night sky now, it's almost, well, it's a different Candace than it was just a few decades ago.
Hmm.
All those extra blinking lights, you kind of wonder, is this the dawn of like unparalleled global connection, or are we potentially tinkering with something far more delicate, our planet's environment?
That's really the core of what we're exploring today. We've
Hmm.
taken a deep dive into the article, Is Starlink Harming the Atmosphere?
Mm,
Just trying to sift through the data and understand exactly what's happening as our skies get, well, busier.
absolutely. And this article really gets into the nuts and bolts of Starlink, you know, that huge project aiming to blanket the globe in internet. The sheer scale of it is just astonishing.
It really is.
We're talking about over 7,000 satellites already in orbit. That's more than a third of all active satellites right now.
Wow.
And they've got the go-ahead for another 12,000.
Right.
And projections suggest we could see maybe, what, 40,000 Starlink satellites and maybe even 100,000 total from everyone before this decade is out.
It's staggering.
So if you're listening and looking to get a solid grasp on this without, drowning in technical papers,
Yeah.
you've come to the right place. This is kind of your express lane to understanding what's going on up there.
Okay, so one of the first things that jumped out from the article is this surprising rate. About 4 to 5 Starlink satellites are deorbiting every single day.
Right. And your first thought is, whoa, is something going wrong?
Exactly. You'd think, that many satellites falling would be a major problem.
Mm-hmm.
But the article clarifies, this is actually planned. It's intentional.
Okay. So it's not a failure. It's like a deliberate strategy.
Precisely. It's intentional deorbiting, a way to manage the constellation, retire older satellites. And crucially, these satellites don't just, smash back to Earth.
Right.
They're designed to completely vaporize way up high as they re-enter the upper atmosphere.
Okay. So no need to worry about bits landing in your backyard.
Not really, no. However,
Uh-huh.
it's this very process, the burning up, that raises one of the big environmental questions.
Okay, let's dig into that then. The article highlights the release of aluminum oxide nanoparticles as these things disintegrate.
Mm-hmm.
And this is where it gets really interesting. There's a study, right, from the University of Southern California.
Yes, and they put some numbers on it. And what's fascinating here is the sheer volume they're talking about. This research suggests each satellite releases roughly 30 kilograms, that's about 66 pounds of aluminum oxide during its reentry.
30 kilos per satellite.
Okay, and when you multiply that by the number of satellites coming down each year, well, the article points to a potential accumulation of over 360 metric tons of this stuff annually in our upper atmosphere.
Wow, 360 metric tons. That's a lot. What's the potential problem with all that aluminum oxide floating around up there?
Well, the primary concern centers on its potential impact on the ozone layer. The article explains that aluminum oxide could act as a catalyst. It might speed up chemical reactions involving chlorine.
Okay, chlorine, that rings a bell, like CFCs.
Exactly. It's a similar kind of mechanism, potentially, to how chlorofluorocarbon CFCs from old fridges and aerosols caused damage to the ozone layer years ago.
Ah, right. So different substance, but a worry it could trigger a similar ozone thinning process just from satellites burning up.
That's the potential, yes.
Mm-hmm.
However, and this is a really important point, the article stresses this remains a potential risk. It's unconfirmed right now.
Okay.
We need a lot more research to really get a handle on the long-term consequences for atmospheric chemistry.
So it's like we spent decades phasing out CFCs because even tiny amounts mattered.
Right, parts per billion.
And now we're intentionally putting tons of something new up there.
Exactly. And while the mechanisms might be different, the sort of underlying lesson is there.
Mm-hmm.
Even things that seem inert might have unexpected effects when you scale them up massively.
Makes sense. Now, the article also mentions another environmental concern briefly. Something about metallic dust affecting the magnetosphere. Sounds pretty dramatic.
It does sound dramatic, but the article is very careful here. It provides context. This specific concern comes from an unpublished preprint,
Ah,
which means it hasn't gone through that rigorous peer review process yet, where other scientists check the findings.
got it. So it's an idea that's out there, but still very speculative, lacks solid scientific backing for now.
Precisely.
Yeah.
It's important to make that distinction. It's not a verified threat at this point.
Okay, good to clarify. Now, shifting gears a bit, one of the first big impacts we did see very visibly was on astronomy, right? Those photos with streaks.
Oh, absolutely. The first generation of Starlink satellites were quite reflective. They definitely caused significant light pollution, appeared as these bright streaks and long exposure images from telescopes. It was a real headache for astronomers.
Yeah, I remember that being a big discussion, but the article says there's been improvement with the newer ones.
Yes, definitely. The second generation Starlinks are a big step forward on the visual front. They've managed to cut their brightness by about 5 times.
5 times, okay.
Better coatings, apparently, and also carefully controlling the satellite's orientation, how it faces the sun and Earth. It's made a noticeable difference in reducing those streaks.
That's good news then, for astronomers, for stargazers. But there's a catch, a bit of a trade-off. The article mentions radio frequency interference getting worse.
Yeah, and this is interesting, isn't it? You solve one problem, potentially create another. Unintended consequences. While these Gen 2 satellites are visually quieter, they seem to be electronically noisier.
Noisier, how so?
They emit radio waves, leakage really, in the 100 to 200 megahertz band. And the problem is, this range directly overlaps with frequencies that radio telescopes use to study the universe.
Ah.
So it's like trying to listen to a really faint, distant radio signal when there's unwanted noise bleeding over it.
And this increase in radio noise, the article says it's pretty significant.
That's quite startling, actually. The article states the radio emissions are a staggering 32 times higher than the earlier versions.
32 times. Wow. And why? Any idea?
The suggestion is it's likely due to less effective shielding of the electronic components on these newer satellites.
Okay, so astronomers might not see as many bright streaks, but they could be hearing a lot more static, basically. That sounds like a whole new challenge.
It is a significant challenge, yeah. But here's a more encouraging bit the article highlights. SpaceX seems to be actively engaging with observatories, collaborating to try and minimize this radio interference.
Oh, that's genuinely positive. That's good to hear. Does it give examples?
Yes, it mentions their work specifically with the Very Large Array, the VLA radio telescope in New Mexico.
Okay, the VLA. How does that collaboration work? What do they actually do?
It's pretty straightforward, actually. The observatories share their observation schedules with Starlink. Then Starlink can try to proactively adjust, maybe tweak the satellite positions, or redirect their signals so they interfere less during those critical times.
And does it work? Is this cooperation making a difference?
Apparently, yes. A study confirmed this kind of coordination can cut the radio interference by as much as 2 orders of magnitude.
2 orders of magnitude.
Right.
So over 100 times less interference.
Exactly. Over a 100x reduction. It shows that solutions are possible when everyone works together.
That's quite impressive. Does it sort of set a precedent, maybe, for how industry should act?
It certainly raises the question, doesn't it? Should this be the model going forward for any company launching these huge constellations?
So taking all this into account then, the deorbiting, the aluminum oxide, the visual improvements, but the radio noise increase, the cooperation.
Yeah.
How does the article kind of sum up the overall worry level right now?
Well, they use this worry meter analogy,
Mm-hmm.
and they place it at a 1 out of 10.
1 out of 10. Okay, so not DEFCON 1.
No, not at all.
Yeah.
The suggestion is that the immediate, directly observable effects are currently considered limited. But, and this is the big but, the sheer scale of what's planned for the future.
Right, that potential 100,000 satellites figure.
Exactly. That sheer number means continued careful monitoring, ongoing scientific scrutiny.
Yeah.
It's absolutely crucial. We just don't know the cumulative effect yet.
So not a crisis now, but definitely something demanding vigilance. And the article uses that analogy to drive the point home, right, about the aluminum cans.
It does, yeah. The analogy of throwing thousands of aluminum cans into orbit and letting them burn up. It really helps you visualize the scale, doesn't it? And how even tiny effects from one satellite could add up to something significant when multiplied thousands or tens of thousands of
Yeah,
times.
it makes it concrete. These little bits of aluminum oxide potentially having this subtle but maybe significant effect on the ozone, or the radio noise impacting our cosmic listening posts. It's that feeling of, well, it's not obviously dangerous yet, but it's a clear call for informed caution as we push further into space. Have we ever done anything like this before? Released so much of one material way up high?
That's a great question. There aren't many perfect historical parallels for this specific material at this specific altitude and scale. We've had other atmospheric impacts, of course, like from volcanic eruptions or industrial pollution lower down, but this sustained high-altitude injection is fairly unique. It reinforces the need for caution.
Right. It's about understanding the potential trade-offs, isn't it?
Precisely.
Yeah.
Ensuring we're not accidentally causing long-term harm to these really delicate planetary systems, just, chasing global connectivity.
Okay, so just to quickly summarize for you, the listener, our deep dive into this article is Starlink harming the atmosphere. It's shown that yes, Starlink satellites intentionally deorbit and vaporize. They release aluminum oxide. This poses a potential risk to the ozone, but it's unconfirmed for now. The
Hmm.
visual streaks in photos, mostly fixed with newer satellites, but trade-off. More radio noise for telescopes now.
Right, a significant increase.
Though encouragingly, SpaceX is actively working with observatories to try and reduce that interference.
And seeing some real success there.
And the overall takeaway from the article seems to be the immediate risks look limited, maybe a 1 out of 10 on the worry scale. But the future scale, the sheer number of planned satellites, that means we absolutely need to keep watching closely.
Exactly. And for you, listening in, hoping to get a quick but thorough handle on this complex issue without getting overwhelmed, we hope this has given you a clear overview of the main concerns, the current state of play, and what scientists are keeping an eye on in this really fast-moving area.
Yeah. And finally, that other analogy the article mentioned, imagining replacing every leaf in a forest with tinfoil.
Mm-hmm. Quite a visual.
It really sticks with you as we get more and more reliant on the connectivity from these huge satellite networks. Just makes you wonder, what other unseen trade-offs might we be making with the really delicate interconnected systems of our planet?
Yeah?
Definitely something to ponder as technology keeps pushing boundaries and our reach extends further and further beyond Earth.